Hi, and welcome back to the channel. As many of you know, I cover a lot of things in this channel, mostly dealing with text-based problems using natural language processing and how they can be applied to more out-of-scope problems, specifically for those in the digital humanities. Now in this video, I'm going to be building on a trend I've been looking at for the past few weeks where we turn away from NLP and look more at image-based problems. Now the nice thing about this video is that it's going to bridge the gap between these two different things that we see covered on this channel. We're specifically going to be looking at how we can use machine learning to embed both text and images simultaneously using a CLIP model. Now, a CLIP model comes to us from OpenAI, which is a great producer of all things machine learning. They're behind things like GPT-3, etc. that you've seen in the news. Now, what makes a CLIP model particularly useful is that both images and text are encoded in the same vector space. The model was specifically trained on images and texts simultaneously. Now, this means that we can use text, encode it, and then use that encoded text to actually search across a database of encoded images. And in theory, we can use it to populate results with text for similar images that match that same query. This might be a little bit difficult to understand, but let's take a look at what we're going to be doing in this video. We're going to be working with 629 images from E-Codices, all of which are cited in the repository under the CSV markdown underneath the data citation.md file. Now, these images have all been encoded. We're going to go through and do all that in this video, but let's say we had a query. Our query was a medieval drawing of a plant. Kind of niche, but we want to find it. We execute this and nearly instantaneously we're able to retrieve results. Now we're going to go through in this video and explain how all this is done so that by the end you can index your own collection of images and find results, but let's take a quick look. What we have here are results that I would consider to be quite good, and we're going to be able to do all this in just a few lines of code. We've got what I would consider to be a plant here, a plant here, a plant here. We've got this medieval chivalry thing going on here, but this isn't too uncommon. A lot of heraldry is going to have floral-based imagery in it, and so that's probably why that's happening there. And again, we're going to be using really small thumbnails here to make the compute a little easier for live coding. But let's say I wanted to just grab maybe some pictures of, let's do something like really interesting. Let's say freedom. What does freedom look like encoded? And what's interesting is we have results in these images that are flags. Flags may be being associated with the concept of freedom, flags hoisted over conquered places, or flags representing a defendable position possibly. I have no idea. But again, this is an off-the-shelf English model that we're using. We're not doing any fine-tuning or training, and we can get some pretty interesting results. Likewise, if I were to type in medieval portrait, I get something that's not entirely as expected, but it's maybe because I'm typing the word medieval in there. Let's try just portrait, and we get some portraits populated for us. These are appearing in some manuscript. I'm not exactly sure which one. Again, you can check the markdown citation to figure out which one these are. And we're going to go through and create a database of embedded images in this video, and then we're going to write the code for actually querying those indexes. And we're going to do this in a couple different steps. Step one, we're going to be using CLIP, as we just saw, to actually encode all of our images. What we're then going to be doing is we're going to be leveraging CLIP specifically through the sentence transformer library. And if you want to, go ahead now, pause the video, and run pip install -u sentence transformers. There is a dash between sentence and transformers. Very important to make sure you get that down correctly. Once we have all of our images embedded, what we're going to be then doing is trying to figure out how they relate to one another. Now, there's a bunch of different ways that we can do this. We can flatten them out with UMap, as we've seen on this channel in the past, and we can explore them in two-dimensional space. But if we want to make an index that's queryable or searchable, we want to use a different approach. And so for this approach, we're going to be using Annoy, which comes from Spotify. Now, Annoy is a great way of finding nearest neighbors or finding things that are similar in a vector space. And Spotify created this to be computationally light and very effective, and it does both of those things. I've run this with 500,000 images and had results within milliseconds. This is scalable and it works exceptionally well. And one of the things that we're going to be doing after this video, in the next video from next week, is we're going to take all the work we do today and we're going to apply it and make it into a nice Streamlit application. So let's go ahead and just jump right in. The very first thing that we're going to do, and I should specify this repository a little bit, there's going to be two sections of this repository. There is YouTube-demo. This is some pre-written out code that's going to look a lot cleaner. Then there's going to be YouTube-live, and this is going to be the coding that we do for this actual video. So let's go ahead and import some of the libraries that we're going to need. So the first thing that we're going to need is we're going to want to import from sentence underscore transformers. We're going to want to import sentence transformer. There we go. And this is going to allow us to import the sentence transformer class, which is going to be what we use to actually embed all of our images with CLIP. Now the next thing that we're going to need to do is we're going to need to say from pill. This is going to be the pillow image library. This comes standard with Python. We're going to be importing image, capital I here. This is going to be what allows for us to actually convert all of our, or open up all of our images and get them into a CLIP model. The next thing that we're going to use is we're going to just import glob. This is a very easy way to just grab all the images from our directory. And then the very last thing that we're going to want to do is we're going to want to grab from Annoy, import the Annoy index. And I always have to copy and paste this because for whatever reason I can never remember correctly Annoy index as the class. And we're going to see each of these. I'm going to explain what each of these are going to be doing as we go through everything in this video. So the very first thing we need to do is we need to get a list of all of our images. Now in this repository, again, you can check out the citation MD file. In this repository, we're going to be grabbing all the images in images. And we see that they're nested in 3 separate folders. These are 3 separate collections of manuscripts. And so what I'm going to use is I'm going to be using glob to create a file list. So we're going to say files are equal to glob.glob. And we're going to grab everything in images. And we're going to use an asterisk here. This is a wildcard. So any folder essentially is what that is saying. And then within that folder, anything that is a .jpg. So all of our JPEGs. And let's just check and see that everything loads correctly. And we have 629 files. I've tested this out. This is what I want to see. The next thing that we need to do is we need to get an image list. Now this image list, we're going to not use cleaner code that we see in the demo. We're going to go through and do it a bit more verbosely live so we can explain what's happening. This is going to be an empty list that we're going to be appending to. And so what we want to do is we want to say for file and files, actually, and we're going to say image.open file. And let's take a look and see what this looks like. And we're just going to say image for this. And then let's go ahead and print off image. And it helps if you actually index as a list. There we go. And what we actually have is a pillow image. Now, what can I do with this? Well, one of the things that I can do if I'm in a Jupyter notebook is I can display it. So I can use display. This comes built in and we can see that image right here. This is a pretty easy way just to display images in Jupyter Notebook. There are better ways. As we can see, this is the opening page of some manuscript. Now, what we want to do is we want to append all those images to that image list. And so what we can do is instead of writing all of this, we can say image list.append, and we are essentially just going to be appending that specific pillow image that is now loaded up into memory. And it's always good just to double check. We want to see that this number corresponds to the one above, and in fact it does. We're dealing with 629 images, files, and images now. So we've got all these images loaded up into memory. Well, what are we going to do with that? Well, what we want to do at this stage is now we want to actually encode those images. And we're going to do that by creating a model. And our model is going to be equal to sentence transformer. And then this is going to take one argument. This argument is going to be the actual model that we want to load up. Now, if this is your first time executing this cell, it is going to take a little bit of time. The CLIP model is quite large. Copy and paste it from our demo. I want to make sure that I get this right. It is going to be clip dash capital V, lowercase I, capital T, dash capital B, dash 32. And this model is going to load up into memory for us so that we can actually use it to create our embeddings for everything in our image list. And it's going to take just a second to load up into memory if you already have it downloaded. If you don't already have it downloaded, it's going to take maybe 10, 15 minutes to download depending on your internet speed, perhaps only a few seconds. Once we've got that loaded up in the memory though, we can actually use that model and actually start encoding all of our images. And we can do this by creating an object called Embeddings, and we're going to call up that model class now and actually have it encode for us all of our data. And if we look at the actual formal YouTube-demo notebook, we'll see a couple different arguments here. And what we're going to be really focusing on is specifically this .encode. Batch size is going to be important because it's going to allow us to work with batches, so this can be done a little bit more quickly. You might need to adjust the batch number depending on your individual computer's RAM. So let's go ahead and use .encode to encode that image list. And I'm going to specify batch size is equal to 32, pretty standard, nothing too large here. And this is going to take just a few seconds to actually run. And again, I'm going to use len embeddings to make sure that the length of my embeddings is again matching 629 so that I know that everything's run correctly. Now on my computer, this is only going to take probably a few seconds. It might take a little longer on yours, depending on your actual hardware. And if you are going to be loading this up and doing it on the GPU, it's going to run much more quickly. Right now, I'm doing everything on the CPU because I feel that it's important to actually do everything on the CPU since most of the viewers of this channel are not using high-end GPUs. And we see that it's already completely done. Now, what do these embeddings look like? Well, let's take a look at what they actually are by looking at this shape. Now, what this tells me is that this has a shape. This is a NumPy array. It's got a shape of 629, the number of files, and 512, the dimensions of each of those images. And if we take a look at what one of these things looks like, we can grab the first array, or the first vector here, and this is what it looks like. A vector of 512 dimensions, which corresponds to each image as it's represented by a CLIP model. So this is how the CLIP model has essentially encoded all of our data. And this is useful. We've got now all of our images stored up in memory, we've got them loaded up, and we've got them all encoded. Now comes the fun part of how do we take what we've just done here and actually create an index for them. And that's going to come, if we're looking at the actual demo file, that's going to come from a little further down after we get past the actual embedding. That's going to come from our index. So our index is going to be from the Annoy library from Spotify. This is going to be where we actually create our index for mapping all of our images. So let's go ahead and create a file called, let's call it Annoy, or an object called Annoy Index. We're going to make this equal to Annoy Index class, and this is going to take two arguments. The first argument is going to be the shape of the images that it expects to see. So in this case, 512. The vectors here are 512, or have a dimension of 512. The next thing is going to be the metric, or the way in which we calculate distance between these things. Now, for our purposes, we're just going to use angular here. I believe you can use cosine, Euclidean, all the kind of standard ways of measuring distance in higher dimensional space. But let's go ahead and execute this cell, and our index is now created as a class. Once your index is created as a class, then comes the fun part where you can actually enumerate over all of your data and add it to that index, each of those embeddings. And then we're going to be able to actually build our index. So let's go ahead and again, do this in a little bit more of a verbose way. We're going to say for IDX, so the actual index number, and then we're going to say for embedding, and then we're going to say enumerate. And enumerate here, for those of you who don't know, is a way of generating an integer that's going to tick up each iteration through the loop, and that integer is going to be represented by the IDX variable. And we're going to say enumerate over our embeddings. And this allows for us to then populate our Annoy index as we iterate through each of those embeddings and actually load everything up into our index. And we can do that by using add_item. So let's go ahead and say annoy_index.add_item, and we're going to add in two things here. The first is going to be IDX. This is going to be the numerical representation of that specific index, so starting at 0 and incrementing all the way up till we get to 628, because again, we have 629 images. And then the next thing that we want to pass in is the actual embedding. So this is going to be locking in the index at position 0, then position 1, embedding 0, and then embedding 1. And if we execute this cell, we see it's already done nearly instantaneously. This now comes the fun part where we actually build out our index. We can use Annoy underscore index. This is going to be calling our class, and we can use build. Now, build is going to take one argument. This is going to be the number of branches that you have in your index. This will be a little bit of trial and error. If you're working with really large data sets, I found that a number of 10 is perfectly fine with up to 100, 200, 500,000. The higher the number that you go here, the more accurate, in theory, your index is going to be for being able to map similarity. But that's going to come at the cost of being a larger file to host. So really, it's up to you on what you want to use here. We're going to use 10 right now, just because that's all we actually really need to. It's a bit of overkill here, but it'll help us have better results. Now, once we have created our index, this comes the fun part where we can use text to then go through and actually analyze and retrieve and populate results. So let's go ahead first and create a text-based query and then encode it with the same model. That's going to be our CLIP model. So let's create an object called query text, and this is going to be equal to model.encode. Now we're going to pass in our raw text here that we want to actually have embedded, and it has to be in a list. Very important here, needs to be in a list. So let's say we're looking for, let's do portrait. We did that a second ago. Let's go ahead and stick with portrait once again. And our goal here is going to be to simply encode our query text, and we can take a look at it. And just like before with our images, it is an array, and it's going to have a shape of, should be just 1, 512, because there's only one item in this collection, and it has a shape of 512, which is what we actually need to have in order to go through and find similarity in our Annoy index. If we look at the YouTube demo, it'll give you all the code for doing just that. So in Annoy, we can grab nearest neighbors by vector, and that's going to be what we actually use to find a similarity in our index. So let's create our results right now. We're going to say res is going to be equal to Annoy underscore index, and we're going to say get underscore nearest neighbors by vector. And I think I've spelled all of that correctly. I'm just going to double check real fast. Get ends by vector, I have. And here we're going to pass in one single vector. Now, it's important that you note, remember that our query text is actually nested in a list. So we need to grab the index at position 0, which is going to be the prompt that we actually have. The next thing is it's going to give us the ability to specify how many results we want to see. So let's just specify 5 for right now. So now we've got loaded up this result. Now, this is the result that's produced by Annoy. As we see here, we've got a list, 36, 6, 609, 22, and 529. What are these? Well, what these are the actual results from our index. And since we know what our index is, because it's mapped to our file names, we can go ahead and we can say for item in res, we can say print item, and then let's go ahead and print files at that index. And we get each individual file that we expect to see. Well, since we know what the index is, and we know where it appears in that list of files, then this means we can print off the actual image as well. So we can do display files item. Oh, image list, I apologize. Image list. We can load up our images right here. And so what we're able to see here is our image list being produced. So we can bring all this together in a single line where we specify a query and we produce a result. And so now I can say medieval landscape, and I can find pictures of medieval landscapes. I can maybe specify a medieval flag, and I get pictures of flags. So I have the ability now, let's do plants, why not? I tested that out earlier, there's a lot of plants in this, and we see medieval plants being populated. So we have ways now of taking text, encoding that text, and then querying an index of encoded images using CLIP through the sentence transformer library and using Annoy. Now, what I'm going to show you in the next video is how to take everything that we've learned in this video and build an entire Streamlit application so that you can not have to write any code at all. You can just load up an image, you could populate a search-based result, and retrieve all these results in a nice, easy-to-use display through Streamlit. I'm also going to be showing you in that video a couple tricks for actually creating a good layout, a grid layout for image displays in Streamlit. That's going to be all for this video though. Hopefully you now have a good understanding of how you can work with both text and images in the same encoded space and retrieve results in an image index using a text-based query. If you get a lot out of this channel, please do consider supporting it via Patreon. As always, thank you so much to all the Patreon supporters and YouTube channel subscribers and supporters. You all help keep this channel alive. All the donations to this channel go right back into the channel to keep making free content for everyone across the world. Again, thank you so much.